Good day, everyone. Today we will discuss our new lesson, which is language processing, humans and computers. But before that, I prepared two questions for you to answer. First, it is the study of language. Yes, you're correct. It is linguistic. Second, it is the method of human communication, either spoken or written, consisting of the use of word. Yes, you're also correct. It is language. Okay, as we all know that language is the way people think as well as they talk, the summation of a point of view. And it holds such power over our minds, decision-making processes, and lives, so it depends to us how we consider, how we might use it to shape the way we think about ourselves and the world. Okay, so let us start our discussion today. So the human mind at work, human language processing. Start with the definition of terms about language processing. Language processing is a term used to describe the series of tasks our brain carries out when we hear and utilize language. So during conversation, when we hear and express language, information is them. Stored passed through several areas of the brain as we hear individual words, interpret them, store information as memories, and finally form our replies. Here is a simplified description of the parts of the brain and the body responsible for language processing. The first one is the inner ear. Okay, in the inner ear, the cochlea reacts to the sound waves of speech and converts them into electrical signals to be followed in the auditory nerve. Okay, in the auditory nerve, these electrical signals are passed directly to the auditory nerve, which in turn carries the signals to the auditory pathway. Okay, so in the auditory pathway, the signals travel through several relay points along the brainstem. So the brainstem decodes the basic signal, checks for loudness and intensity, then decide whether reflex actions are needed. And then, the fourth one is the auditory cortex. Okay, on the auditory cortex, this is the part of the brain where electrical signals are finally interpreted as sounds, so memorized, then recognized as words or other types of sounds, to be followed by the Wernicke's area. In the Wernicke's area, the part of the brain primarily responsible for comprehending language, so comprehension is a complex process. And then, in the Broca's area, when we express ourselves verbally, the words we choose are passed to the Broca's area of the brain. So it controls speech production, coordinating the signal to our mouth, tongue, and vocal cords. Okay, the last description of the parts of the brain that are responsible for language processing is the physical production of speech, wherein it is the final step in language processing is to physically produce our own speech. Our tongue, lips, vocal cords, and lungs all act in coordination to achieve this. Psycholinguistic is the area of linguistics that is concerned with linguistic performance, how we use our linguistic competence or sign production and comprehension. The human brain is able not only to acquire and store the mental lexicon and grammar, but also to access that linguistic storehouse to speak and understand language in real time. We usually have no difficulty understanding or producing sentences in our language. We do it without effort or conscious awareness of the process involved. Okay, example. The horse raced past the barn field. So, and some grammatical sentences are easy to understand. Example, the baby seems sleeping. So this means that language processing is more than grammar alone. These are psychological mechanisms that work with the grammar to allow us to produce and comprehend language. Speaking and comprehending speech can be viewed as a speech chain, a kind of brain-to-brain linking as shown in the next slide. Okay, so when we say speech chain, it is a speech communication consists of a chain of events linking the speaker's brain with the listener's brain. Okay, so 5 steps or lengths of speech communication that describe the process by which the speaker's brain is connected with the listener's brain to communicate. The first one is the linguistic level. In the linguistic level, it is the beginning of the transmission of a message, okay, to be followed by arranging thoughts, deciding what to say, putting what to say into linguistic form, and then selecting words, phrases, and sentences in accordance with the grammatical rules. And then last, it is the planning already of a message delivery in a pragmatically appropriate way. Okay, it is to be followed by the physiological level. Okay, in the physiological level, activation of the speech systems, specifically muscles, in the form of impulses along the motor nerves, and then it is involving lungs, vocal folds, tongue, lips, teeth, to name a few. Okay, so the third one of the speech chain is the acoustic level. Okay, in the acoustic level, it is the pressure changes in the air due to the movements of speech systems, which is called the sound waves or the acoustic waves. Okay, it is to be followed by the physiological level. Okay, under physiological level again, it is the hearing mechanism already activated. Nerve impulses travel along the listener's auditory nerves. To be followed by the last speech chain is the linguistic level. Okay, under the linguistic level, it is the recognition already of the speaker's messages, activities in the listener's brain modified by the nerve impulses. Okay, the 5 steps in the speech chain is the first is the linguistic level. It is pertains to the sender or the speaker. Okay, there are 2 parts under the linguistic level. The first one is this intention. So what is the intention of a sender or the speaker to us? Okay, so thoughts takes place in the higher level of the brain center. Under the second is the language. Okay, under language, the brain translations thoughts into words which are then assembled in the proper order and form. Okay, step 2 of our speech chain is the physiological level of sender and speaker. So under that, the motor execution already and muscle activity. Okay, so motor nerves activate the respiratory, the phonatory, and articulatory muscles. It has to send a signal to create every single phoneme, and then many muscles involved in speech production. So let us now move on to the speech signal. When you say speech signals are sounds defined as pressure variations traveling through the air. So these variations traveling in pressure can be described as sound waves. As speech sounds can be described by their acoustic or the physical properties. So the vibrations of our vocal cords cause vibrations of air pressure, and sounds we produce can be described in terms of the following. The first one is the fundamental frequency or the pitch. It is how fast the variations of air pressure occur. The second one is the intensity. It pertains to the magnitude of the variations which determines the loudness of a sound. Okay? When we say spectrograms or the voice prints, these can be created by computers and are used to analyze speech sounds. It is also indicates the intensity formats, which is the strongest harmonics produced by the shape of the vocal tracts during production, and pitch of speech sounds, and demonstrate how different speech sounds have recognizably different acoustic properties. Okay, next is the speech perception and comprehension. Okay, it is how the listeners perceive and comprehend the word that is incoming to his or her ear. So when we say speech, it is a continuous signal. So in natural speech, sounds overlap and influence each other, and yet listeners have the impression that they are hearing discrete units such as words, morphemes, syllables, and phonemes. So another, the lexical axis or the word recognition. Okay, so when we say word recognition or the lexical axis, it is the process of searching your lexicon for phonological strings that correspond to words. It is a central problem of speech perception is to explain how listeners carve up the continuous speech into meaningful units that refer to as the segmentation problem. We have the two models of speech perception. Okay, the bottom-up and the top-down models. So many psycholinguistics believe that language perception and comprehension involve these two models, which is the top-down processing and the bottom-up processing. Okay, the first one model is the top-down processing. Okay, in the top-down processing, it is proceed from semantic and syntactic information to the lexical information gained from the sensory input. So listeners can predict that if a speaker says the determiner the speaker begins constructing an NP and expects that the next word could be a noun, as in the boy. In this instance, the knowledge of phrase structure would be the source of information. So the second one model is the bottom-up processing. And the bottom-up processing, it is moving from the sensory phonetic input to phonemes, then morphemes, and etc., and then up to semantic interpretation. So in this, listeners wait until hearing the and boy constructing an NP and then waits for the next word and so on. Lexical access and word recognition. When you say lexical access, it is defined as the way which individual access words in the mental lexicon. It can be examined using lexical decision experiments. For example, the word doctor will be faster if you just made a lexical decision on nurse. So this effect is known as semantic priming. We say that the word nurse primes the word doctor. So this leads researchers to believe that frequent words are more easily accessed in the lexicon than infrequent words. When you say word recognition, it is the ability to identify, read, and analyze the meaning attached to the word. So it is the basic foundation skill in reading upon which learning of advanced reading skills depends. Okay, so let us now move on to syntactic processing. When we say syntactic processing, it involves a series of steps including tokenization, part of speech tagging, parsing, and semantic analysis. Okay, when we say tokenization, it is to split paragraphs and sentences into smaller units that can be more easily assigned meaning. The tokenization helps in interpreting the meaning of the text by analyzing the sequence of the words. For example, the text, "It is raining," it can be tokenized into "It is raining." So the tagging. Tagging, it is also called grammatical tagging. It is the automatic assignment of part of speech tags to words in a sentence. For example, if the word ends in tion, it is assigned the tag, it is a noun. So if the word ends in ment, assign the tag, also noun. If the word is all uppercase, assign the tag proper noun. So if the word is a verb ending in ing, it is assigned the tag verb. The next one is the parsing. When you see parsing, it is the grammatical analysis of a sentence including identifying the subject, verb, and object. For example, a natural language processing algorithm is fade a sentence. The dog barked. Parsing involves breaking the sentence into parts of speech. Example, dog, it is a noun, and then the bark is a verb. Okay, so the next one is the semantic analysis. It is the purpose is to draw exact meaning, or you can say dictionary meaning from the text. The work of semantic analyzer is to check the text for meaningfulness. The most important task of semantic analysis is to get the proper meaning of the sentence. For example, analyze the sentence, Ram is great. In this sentence, the speaker is talking either about Lord Ram or about a person whose name is Ram. That is why the job to get the proper meaning of the sentence of semantic analysis is important. Let us now move on to syntactic processing. Okay, so listeners need to build phrase structure representations of sentences as they hear them in order to understand the sentence. They must place each incoming word in a grammatical category and disambiguate messages. So garden path sentences. The garden path sentences, it is a grammatically correct sentence that starts in such a way that a reader's most likely interpretation will be incorrect. For example, the horse raced past the barn field. People naturally interpret raced as the main verb when in fact the main verb is fell. Okay, next is the syntactic processing. Okay, so the mind uses two principles in parsing sentences that lead people to go astray when encountering garden path sentences. Okay, so minimal attachment. It builds the simplest structure consistent with the grammar of the language. For example, in the string, the horse raced past the barn field, the simpler structure is the one in which the horse is the subject and the raced is the main verb. Okay, so when you say late closure, it causes new words or phrases to be attached to the current clause. For example, John said he would leave yesterday. Would be parsed as John said he would leave yesterday, and not as John said he would leave yesterday. In this example, he spoke yesterday. Next is the speech production or the planning units. When you say speech, it is one of the most natural forms of communication for human beings. So it is how we produce words and sounds. Okay, so when you say speech production, it is already the process of uttering articulated sounds or words. For example, how humans generate meaningful speech. So it is a complex feedback process in which hearing, perception, and information processing in the nervous system and the brain are also involved. Although speech sounds are linearly ordered, slips of the tongue, including phonerisms, reveal that speech is conceptualized before it is uttered. Okay, so there are intended speech. Okay, for example, the ad hoc. So the actual of that is that the ad hoc. So this type of errors reveals that the second word has already planned. Interestingly, phonological errors primarily occur in content morphemes rather than function morphemes, and function morphemes are not interchanged like content morphemes. Okay, next is the speech production or the lexical selection. When you say lexical selection, it is the process by which we access and fit an appropriate word to ongoing speech and is core process for language production. So it provides a way to deal with what you do when a single word in one language translates to more than one word in another language. For example, Mihika plays with her dog every day. So the lexical verb in the sentence is plays. Plays is the action word that is done by the subject Mihika. So word substitutions are seldom random. We tend to accidentally replace a word with a semantically related word. So sometimes we produce a blend, which is part of one word and part of another. So for example, of the word splinters and the word blisters. So when we blend that word, it will become splisters. So another word is the edited and then annotated. When we blend the word, it will become editated. So segments tend to stay in the same position in this blend errors. Application and misapplication of rules. Sometimes speakers also make errors with morphological and syntactic rules. It is difficult to say this process in normal error-free speech, but when someone says groupment instead of grouping, and also sometimes they say ambigual instead of ambiguous, and or sometimes blooded instead of bloody. So it shows that regular rules are applied to combine morphemes and form possible but non-existent words. So in an error such as saying a burly bird instead of an early bird, the appropriate allomorph a instead of an is chosen even though the speaker did not intend to produce a noun starting with a consonant. So this tells us that the rule to choose a or an must apply after early was accidentally switched to barley. Next is the non-linguistic influences. Non-linguistic factor can also contribute to speech production. So the individual who said he made hairlines instead of he made headlines was referring to a barber. The fact that the two compound nouns both starts with the same sound are composed of two syllables, have the same stress pattern, and contain the identical second morphemes. So other errors such as the actual utterance, it is, I've never heard a class on April 9th, instead of the intended utterance on a Good Friday. So Good Friday was on April 9th that year. So even though Good Friday and April 9th have nothing in common phonologically or morphologically, the non-linguistic association was enough to prompt such an error. We are already done discussing about the language processing. Now, let us discuss about the computer processing of human language. So until a few decades ago, language was strictly humans only. Others need not apply. So but today, it is common for computers to process language. So computational linguistics, it is a subfield of linguistics and computer science that is concerned with the interaction of human language and computers. It includes the following: the analysis of written text and spoken discourse. Next is the translation of text and speech from one language into another. And then the use of human, not computer, languages for communication between computers and people. And then the modeling and testing of linguistic theories. So according to John F. Kennedy of 1917 to 1963, man is still the most extraordinary computer of all. Let us first define what is computer. So the word computer, it comes from the word compute, which means to calculate. It is an electronic device which stores and processes data to give meaningful information. Processing is done with the help of instructions given by the user, which are also stored within the computer. In other words, a computer is a device that accepts information and manipulates it for some result based on a program. Maybe it is a software or sequence of instructions on how the data is to be processed. Okay, next is the computational phonetics and phonology. The two sides of computational phonetics and phonology are concerned with the following. The first one is the speech recognition. It is the process of analyzing the speech signal into its component phones and phonemes and producing, in effect, a phonetic transcription of the speech. So note, and speech recognition is not the same as speech understanding, as is commonly thought. Rather, speech recognition is a necessary precursor or beginning to the far more complex process of comprehension. The second one of computational phonetics and phonology that are concerned is the speech synthesis. So when we say speech synthesis, it is the process of creating electronic signals that simulate the phones, the prosodic features of speech, and assemble them into words and phrases for output to an electronic speaker or for further processing as in speech generation application. With the advances in the acoustic theory of speech production and the technological developments in electronics, machine production of speech sounds has made great progress. We no longer have to build physical models of the speech-producing mechanism. We can now imitate the process by producing the physical signals electronically. Speech sounds can be reduced to a small number of acoustic components. One way to produce synthetic speech is to mix these components together depending on the speech sounds to be imitated. It is rather like following a recipe for making soap, which might read as: take 2 quarts of water, add 1 onion, 3 carrots, a potato, a teaspoon of salt, a pinch of pepper, and stir it all together. This method of producing synthetic speech would include a recipe that might read: first, start with a tone at the same frequency as vibrating vocal cords. If it pertains to a woman's or a child's voice is being synthesized, it is higher. And if it is for man's, it is lower. So emphasize the harmonics corresponding to the formants or quality of a speech sound required for a particular vowel. So liquid or nasal quality or a speech sound pronounced by the voice resonating in the nose. For example, the letter and Add hissing of buzzing for fricatives. The sounds v, z, and z are some examples of English fricatives. Add nasal resonances for nasal sounds, and then temporarily cut off sounds to produce stops and affricates. All of these are blended electronically using computers to produce highly intelligent, more or less natural sounding speech. More interactive phone system and cell phones have small vocabularies that allow for unlimited number of messages. So these systems search the speech signal for anything resembling stored words. More advanced systems must be trained to a speaker's particular voice and uses phonotactics and statistical analysis to recognize speech. If a sound that could be l or r occurs after a d sound, then computer knows that r is the correct sound, not l. If the computer cannot distinguish between the l and the r sound and therefore must decide between the rate and late in H2 blank, it can either use knowledge of syntax to choose late or can use statistical knowledge that it's too late, occurs much more often than it's too late, and thus chooses late. So but people are much better at filtering out irrelevant sounds and focusing on the voice of a single speaker, which is known as the cocktail effect. Another approach is known as concatenative synthesis. And this approach, it relies on recorded units from humans that are assembled to form the desired utterance. Okay, the next text is to text-to-speech. Text-to-speech program, it converts input text into phonetics representation or whatever units are to be combined. Okay, we have two problems encountered with text-to-speech programs are the following. The first one is the homographs that pronounce differently. So in the homographs, complex structural knowledge required to know whether to pronounce read is read or read in the following sentences. Okay, the first one, I have read the book. Okay, letter B, which girl did the teacher have read from the book? Okay, so in this structural knowledge, okay, you have to pronounce correctly if it is a read or read in the following sentences. Okay, the second one, you have to, there are some also problem, okay, especially in spelling. There is inconsistencies in spelling. So computers now have memory to compile every word that is spelled similarly but pronounced differently, like tough, bow, cuff, and dough. But new words are always being added to each language, and text-to-speech programs need rules for converting any new words into speech sounds. Okay, so moving on. So let us now tackle about the computational morphology. So when you say computational morphology, it is the process of word structures by computers. So it is the host of interwoven rules, exceptions, and word or morphemes or forms, all with the purpose of comprehending the internal structure of word. So computers also need to understand morphology and be able to understand morphemes. To process words, the computers is programmed to look for roots and affixes. Okay, in some cases, this process is straightforward, like as follows. Okay, so the first one is the books. It is easily broken into book, added with S. The second one, fondness, into fund, added ness. And the third one is walking, into walk, added ing. And the last one, unhappy, into unhappy with an prefix an and happy. One strategy would be to compile all the morphological forms of all the language words into a dictionary. But the dictionary would constantly be out of date as new words enter the language. So not all forms are predictable. So it would be impossible to predict a new compound like podcast or the plural form of fox. So the computer needs to have the ability to break words correctly into their component morphemes and where the word can be placed in a sentence. So, when we say stemming, it is the one method of morphological analysis wherein it is the process of detecting affixes and stripping them from roots to identify morphemes. So, for example, the computer would detect and strip the be and the ed from befriended. So, then would identify those morphemes in its dictionary. Okay, moving on. Let us now discuss what is computational syntax. Okay, computers must also be able to determine the syntactic structure. A parser, it is a program that uses grammar to assign phrase structure to a string of words, or it is a program that breaks down into recognized strings of characters for further analysis. So we have two types of parser. The first one is the top-down parser. So under the top-down parser, it proceeds by first consulting the grammar rules and then examining the input string to see if the word or first word could begin an S. Okay, the second one is the bottom-up parser. It looks at the input string first and then finds the phrasal categories. Okay, when parsing a sentence, a parser may make faulty assumptions about syntactic categories or structure. Say, the parser could then backtrack to properly parse the sentence. Or, the parser may parse all the possible structures in parallel and then only parse that finish are accepted as valid. So, according to Edmund Burke, 1790, good order is the foundation of all things. Okay, next is the computational semantics. Okay, when we say computational semantics, it is concerned with the following. The first one, okay, it is to produce a semantic representation in the computer of language input. The second one is to take a semantic representation and produce natural language output that conveys the meaning. Another, to generate sentences, the computer must find words to represent the concepts to be conveyed. Then, the syntactic rules will apply to these words. So in order to achieve speech understanding, the computer must find meanings that fit words and structures of the input. Okay, next is the compositional semantics. Okay, in the compositional semantics, the relationships between words can also be demonstrated with a network like those used for computational syntax. So this model means that you is to do the verb, which is the agent, and the switch is to be acted upon by the verb, which is the them. Okay, so you is the agent. Okay, next is to put up. Okay, the switch is the them wherein it is acted upon by the verb. Okay, it is the them. So it is also the system can use a formal logic for semantic representation such as put up or you, which is the switch. The computer can check for truth values in this way by checking if the pair comprised of you and the switch are included in the set of pairs that represent the meaning of put up. Okay, moving on, let us now discuss about the computational sign language. Okay, research linguists at Boston University are working on computers algorithms that will recognize sign language much in the way that speech may be recognized. So the signers may sign in front of a camera. So like speaking into a microphone, and a computer will attempt to match the sign from a set of prestored sign via visual processing, just as it will attempt to match a sound from a set of prestored acoustic waveforms via audio processing. So the visual processing in this case means detecting the shapes and gestures of the hands, their trajectories, and their orientations. So these are difficult algorithms to construct, and success has so far been limited. Twofold purpose of these enterprises why they do the research. It is the first one, to produce a video dictionary of signs. It is someone who can imitate a sign but doesn't know its meaning can look it up in the video dictionary. The second one, it is to enable a computer to search through ESL videos for a particular sign, just a search engine like Google searches for certain keywords in text documents. Once again, we said that sign languages share all the advantages and disadvantages that are part of language in general. Moving on, let us now move on to discuss about the computer models of grammar. So computers and people are different, right? They are different and they achieve similar differently. Just as an efficient flying machine is not a replica of any bird efficient. Efficient grammars for computers do not resemble human language grammars in every details. So computers are often used to model a physical or biological system which allows researchers to study those systems safely and sometimes even cheaply. For example, the performance of a new aircraft can be simulated and the test pilot informed about safe limits in advance of actual flight. Computers can also be programmed to model a grammar of a language. An accurate grammar, one that is true of a speaker's mental grammar. It should be able to generate all and the only sentences of the language. Failure to generate a grammatical sentences indicates an error in the grammar because the human mental grammar has the capacity to generate all possible grammatical sentences. So this is the logic flow of machine translation of speech. It is begin with the speech source. Next is the speech recognition system. Okay, so the third one is the text source. Next, it is translated already by the computer. And then what is the text target? It is to be followed by the speech synthesis system. And then lastly, it is the speech target. Okay, moving on with a computational forensic linguistics. When we say forensic linguistics, it is a subfield of linguistics that applies to language as used in the legal and judicial fields. It includes the following. The first one is the authorship studies. The second is the interpretation of legal language. The third one is the language rights and usage in the courtroom. The fourth one is the statement analysis. For example, the suicide notes. Okay, the fifth one is the trademark protection and infringement. The sixth one is the speaker already identification. And the seventh one is the text authentication. And the seventh is the legality of lip reading, and so on. Okay, let us now move on to the computational forensic linguistics. It is a sub-area that concerns itself with computer. It is the application in forensic linguistics. In this section, we will look at three such applications. The first one is the trademarks, interpreting legal terms, and speaker identification. Okay, let us now first discuss the trademarks. Okay, there is a risk that the word Google could become so commonly used that it becomes synonymous with the word search. When this happens, we could lose protection for this trademark, which could result in other people using the word Google to refer to their own products, thus diminishing the brand. The second one is that interpreting legal terms. Okay, in this case, a recent case hinged on the legitimate use of the word Visa, not as a credit card trademark, but as a legal term relevant to international travel. Okay, the last one is the speaker identification. Okay, when we say speaker identification, it is the use of computers to assist in such a task as opposed to ear witnessing, which relies on the judgment of human listeners. Before I end my discussion, so let me first read the quotation of Cliff Kwang. According to him, whether we're communicating with a human or a machine, the goal is to create a shared understanding of the world. That's the point behind both the rules governing polite conversation and how a user-friendly machine should work. Once again, I'm Rosalia M. Tapia. Good day.